All right, everybody, here is the homework number 10 notes part 2, which is focusing just on the range part of things. And we're going to do these range problems without graphing. And the way we're going to do them is by thinking about just kind of like how big or how small you could make the function by picking different x values. So we do kind of have to be thoughtful about the domain here as well. So looking at this function, 36 f of x equal to 36 minus x squared, I know that I need 36 minus x squared to be bigger than or equal to 0. I'm going to factor this as 6 minus x times 6 plus x. And then the numbers that go on the number line are 6 and negative 6. Pick a number bigger than 6, like 7. 6 minus 7 is negative. 6 plus 7 is positive. Negative times positive, negative. And then there's a way you can find the rest of these without actually keeping doing that. And instead of keeping on picking points and finding the overall sign, you can look at where the 6 came from. The 6 came from the 6 minus x. It's raised to the first power. If it's raised to an odd power, the sign is going to change. So it goes from negative to positive, and then negative 6 came from this factor. It also has an odd power, so it's going to change from positive to negative. You can check for yourself by plugging in points, but it does work. If you plug in 0, the whole thing's positive. Plug in negative 7, the whole thing's negative. We want this to be positive, so we have a domain of everything from negative 6 to 6. And not that we were asked to find it, but our domain is all real numbers from negative 6 to positive 6, inclusive. So now I want to talk about the range. So when I'm thinking about this, what I'm thinking of is I want to pick values of x that will make this whole thing as big as possible or as small as possible. I'm going to point out here that if I'm subtracting x squared, I actually want to make x squared as small as possible to make this quantity as large as possible. The smallest I can pick for x squared to be, the thing I can pick to make x squared the smallest is x equal to 0. 0 squared is 0, and any other number I pick for x will give me a bigger result because when you square something, it always gives you a non-negative output. So I know that if x equals 0, f of 0 is going to be the square root of 36 minus 0 squared, which is the square root of 36, which is 6. And that's the biggest this can be. Any other pick for x will make this inside part smaller. Like if you pick 1, f of 1 is going to be the square root of 35. F of 2 is going to be the square root of 32. To make this thing as small as possible, I want to make x as large as possible. The biggest x can be is 6, or negative 6 is kind of the furthest away from 0. And if you plug in either one of those, f of 6 is going to be the square root of 36 minus 6 squared is also 36, which is going to be the square root of 0, which is 0. So the biggest value we get is 6, the smallest value we get is 0. So it looks like our range here has a low of 0, where you can't take a square root and get a negative number out, and the high is 6, inclusive. That's how you would approach something like this. Look at the next question, which is very related. So now we're looking at the range of g of x equal to 1 over the square root of 36 minus x squared. So here's what I know. I know that the square root of 36 minus x squared has a range that's between 0 and 6. So then if I take the inverse of this, or the reciprocal of this, I know that 1 over the square root of 36 minus x squared is going to be bigger than or equal to 1/6 and less than or equal to, well, 1 over 0 is kind of terrible, but I'm going to point out here that we're really on the positive side of 0. And if you take the reciprocal of a very, very, very small positive number, it's going to be a very, very large positive number. So I should lose the equals to part here and say that it's going to be less than infinity. So imagine we picked x equal to something really close to 6, like 5.99999, and plugged it in and gotten a number that was very, very close to 36. 36 minus, in fact, let's not. So, right, you have some very, very small number, and then 1 divided by a very, very small number is very, very large. On the other hand, if x is equal to 0, you get the square root of 36 minus 0, which is 6, and then 1 over 6 is just 1/6. So our range here is everything from 1/6 to infinity. Again, that might seem a little bit kind of quick there. Is there more I can say? Not really. I'll just point out, right, like, so imagine, right, if you pick bigger values of x, like if we picked x equal to something easy, like let's say that x was equal to the square root of 35. Then f of the square root of 35 is going to be 1 over the square root of 36 minus square root of 35 squared is 35. And that's going to be 1 over the square root of 1, which is just 1. So you can see, like, oh yeah, if x is something that's close to 6, we're getting values that are bigger than 1/6. I know that doesn't seem like it's very big, but if you pick, so I would encourage all of you to pick something like x equal to 5.99999. In fact, yeah, let's go ahead and do it just because I think it's worthwhile. Let me grab my calculator real quick. Sorry. I really want you to see and believe that this is true. But if an original function is getting very, very close to 0, that the reciprocal function is going to get very, very large. Let's take a look here and see. So if I do 5.99999 squared, and I do 36 minus that, and I take the square root of that, and then I do 1 divided by that. See, we're getting kind of big, 91. So, and if you pick values even closer to 6, your results would get even larger and larger and larger. So I think that's enough justification there. Let's look at the next few examples here. Find the range of 20 over x to the 6 plus 5. I'll point out two things here. X to the 6 plus 5 is something that's always greater than or equal to 0, because x to an even power is never negative. So I know that my whole denominator, x to the 6 plus 5, is always going to be greater than or equal to 5. So if I pick x equal to 0, I'll make the denominator as small as possible. F of 0 will be 20 divided by 0 to the 6 plus 5, which is 20 divided by 5, which is 4. If I make the denominator as small as possible, I've made the fraction as large as possible. And then if I pick bigger values for x, my fraction is going to get smaller and smaller and smaller, because if you divide by a bigger number, the overall result gets less and less. For example, if I pick x equal to 1, f of 1 is going to be 20 divided by 1 plus 5. And 20 divided by 6 is 10/3, which is 3 1/3, or 3.33 forever. Oh, it got smaller. And if you get right, and you pick x equal to 2, even smaller, f of 2 is going to be something like 20 divided by, let's see, 2 to the 6th power is 64, plus 5 is 69. 20 over 69 is like, I don't know, definitely less than 3 1/3, right? It's like, I don't know, let's find out. 20 divided by 69 is 0.28. So we're getting smaller and smaller and smaller. And we can see that as x gets larger and larger, this function is getting closer and closer and closer to 0. It's never going to equal 0, because for a fraction to equal 0, the numerator has to be able to be 0, and 20 can't equal 0. It's 20. But we're going to get super close to 0. So as x gets big, as x gets larger and larger and larger towards infinity, f of x approaches 0. So we have a high value of 4. We have a low value of almost 0. So it looks like our range is everything from 0 exclusive to 4 inclusive. Always we put the smaller numbers on the left, the bigger numbers on the right. Same kind of idea here. Find the range of the 4th root of x to the 8th plus x squared plus 81. I'll again say x to an even power is always bigger than or equal to 0. So x to the 8th plus x squared has to be bigger than or equal to 0. The smallest this can ever be is if I pick x equal to 0. So if I do g of 0, if I put x equal to 0, g of 0 is going to be the 4th root of 0 plus 0 plus 81, which is the 4th root of 81. But 81 is 3 to the 4th power, so that's going to be that's just going to be 3. And that's the smallest this can ever be. And then if I pick larger and larger values of x, this thing's just going to get bigger and bigger and bigger. If you pick like x equal to 7, let's say 10, right? 10 to the 8th is like, I don't know, 100 million plus another 10, right? You're getting very large very quickly. And you can get larger and larger and larger. So it looks like as x gets bigger, g of x also gets super duper big. So it looks like our range here, we have a low value of 3, and we're including 3. And then you can get any larger number you want. So again, we're just trying to think about the x values that make our function either as small as possible or as large as possible. Last page here. Okay, so this is kind of the same thing as before. We just saw that the range for this for what is the denominator of this new function was everything from 3 to infinity. So now we're going to say, great. So we know that this part for the fourth root of x to the 8th plus x squared plus 81 is always between infinity and 3. So then we're going to take the reciprocal of all sides. And when you take the reciprocal of an inequality, it actually changes the direction of the order of the inequality. For example, it's true that 2 is less than 3. And it's also true that 1/2, the reciprocal of 2, is bigger than 1/3, the reciprocal of 3. So whenever you take reciprocals of both sides, you have to change the direction of the inequality. So here we're going to have 1/3 bigger than or equal to 1 over the fourth root of x to the 8th plus x squared plus 81, bigger than the reciprocal of infinity, although I should say, right, if you take a really big number and you take the reciprocal of a really big number, it's a very, very small number. It's getting really, really close to 0. And then we're going to multiply everything by 6 because there's a 6 on top. So 6 over 3 is bigger than or equal to the function we have is bigger than 6 times 0, which is still 0. So it looks like our function is between 0 exclusive. Oh, sorry, you can't quite say that. Apologies. It looks like our function is between 0 exclusive and 2 inclusive. So it looks like our range here is everything from 0 to 2. Again, if you pick a number, if you pick x equal to 0, you get 0 plus 0 plus 81. The fourth root of 81 is 3. 6 divided by 3 is 2. And then if you pick any larger value of x, the denominator gets larger, which means the fraction gets smaller. I will point out that is a very common theme that comes up in calculus a lot, that when the denominator does one thing, the overall fraction does the opposite thing. And so that's something I would really encourage you all to remember, is that when the denominator gets big, the overall fraction gets closer to 0. And when the denominator gets small, the overall fraction gets larger and larger and larger, possibly negatively larger. So it either gets larger like infinitely large or larger like negatively infinitely large. Last question here. Oh yeah, by the way, the code for the homework, if you want to access the homework before Monday at whenever class starts, is intense. 10 for tens, or 10 for the homework assignment number 10. So it's lowercase in, capital T, capital E, capital N, lowercase se. Okay, last question here. And this question is similar to the one that we did in the previous video. I want to find the range of this function here. So this one requires simplification. So I'll point out that if we simplify this, the top factor is as x minus 2 times x minus 7. And the denominator factor is x minus 2. And before we cancel, we're going to point out that in the domain, sorry, I spelled that terribly. In the domain, x can't equal 2. Or if you wanted to be specific about it, you'd say everything from negative infinity to 2. But I don't really care because I'm not asked about the domain here. I'm just asked about the range. Don't need to be super specific about how I write it. But then when we cancel this function becomes g of x equal to x minus 7 as long as x isn't 2. And again, it's a straight line. And straight lines that aren't horizontal, right? If it's got a positive slope or a negative slope, you'll get every y value. Except here, if we plug in 2, which we can't do, we would get -5, which we won't get. So x equal to 2 is excluded from the range, and g of 2 equal to 2 minus 7 equal to -5 is excluded from the range. So -5 is something y can't equal. So, right, g of x can't equal g of 2 because they're not allowed to actually plug in 2. But we still plug it in to see what the value would have been to exclude it. So here our range is everything except for -5. So negative infinity to -5, union -5 to infinity. And I'll point out again, if you were to graph this, it would look like a straight line, except you'd be removing one point, the point where x is positive 2 and y is -5. All right, that's it for the range video. Again, if you're looking for the access code for homework assignment number 10 before Monday at class time, it is intense, where the letters of the word 10 are capitalized and everything else is lowercase. So lowercase I, lowercase n, uppercase T, uppercase E, uppercase N, lowercase s, lowercase e. That's all.